Thank you very much, by the way. All right, so here we go. It says you are cutting fabric for placemats that are 13 3/4 inches wide. If you have a piece of fabric 82.5 inches long, how many placemats can you cut from the fabric? No, not 6 inches, but 6 what? 6 what? What are we cutting?
6.
Say it.
6.
Yeah, 6 placemats. All right, that's why I think it's important for you to understand the units. Very important to understand the units. Now, tell me how we got that real quick. Hold up. We did 82 1/2 divided by 13 3/4. Beautiful. And that was 6. Well, and that's a very good question. So here we go. What I'm going to do is I'm going to try to see if I can make it make sense. All right. Jack, listen. I'm have a tough test coming up. All right. There's going to be no interference today. All right. I mean that. Sean, I'm not sure what you're doing. You're gonna have to do me a favor. This right over there. Sean, get up here. No, I don't want you using that. No. Yes. Right here. Now, if you want to borrow one, there's right here. Hey, there's one right there you can borrow for today. Let's go, Sean. All right. Now, what I want to do is I'm going to try to demonstrate why this is a division problem. So what I want to do is I'm going to draw this long piece of fabric. All right. And this is the fabric that we're talking about right here. All right. So again, what I have now is this is 82.5 inches. Stay with me, please. That's 82.5 inches. Now I'm going to start cutting it up into placemats. So here's what I did. I cut a piece here. Now, does that kind of look like a placemat? Yeah, we could call that a placemat. And right now, that is 13 3/4 inches. Right? So then I'm going to do what? Cut another one. Right? Now, what am I actually doing to the 82.5 inches? What am I doing? No, I'm what? You see it? Okay. Go ahead. What am I doing? There you go. And what does splitting it up mean? Yes, that's how you should be thinking about it. I'm taking the 82.5 and I'm dividing it up. I'm dividing it up into 13 3/4 inches. That's how you can kind of visualize it. Now, once again, just because it has a fraction, all right, don't be confused by the fractions. If you don't like the fractions, make the numbers easy for you, like 82 or like 80 and 20. If I said you have fabric 80 inches and you had to cut it into 20-inch pieces, most people can say, well, that's obvious, that's 4. But as soon as I say fraction, they start having a little trouble with it. All right? Good job. Good start so far. All right? Now, I want 22. Xavier, read. Go. 37 4/5 divided by 7/10. Tell me what that was.
I got 37 and 1/2.
Read it to me, please.
37 4/5 divided by 7/10.
No, I'm asking you to read the problem.
Oh, the largest and the smallest size on record measured about 37 inches and 7 long, respectively. How many times measure is
Okay, so now I want to ask you this question. Please pay attention. Everybody else, look up on the board. Stop talking. Let's say I said the largest one was 20 inches and the smallest one was 2 inches. How many times bigger is it? 10 times bigger. How do you do that with those two numbers? 20 divided by 2. So what do you think I do with 37 and 4/5 and 7/10? Just divide it. Now take your calculator out and divide it real quickly, and then tell me what the answer is. That's what I'm talking about. Change the numbers into something that makes sense. Put your hands down. Shh. Yes. Ask a question when it's time. What did you get? That's exactly correct. 54 times. That is exactly correct. It's 54 times greater. Now, of course, it's kind of hard to see 37 and 4/5 divided by 7/10 is 54. But I can assure you that is the correct answer. All right? You understand that? What?
I feel if there was a question like this on the test, I wouldn't understand what it meant when it said about 37 and 7 inches and 4/5 inches and 7/10 inch long, respectively.
You know what respectively means? No, respectively just means they're talking about the 37 and 4/5 is the largest. That goes with the first one. And the smallest is the 7/10. That's all that means. All right? Now, it says how many times larger. So to figure out how many times larger something is, we would just divide. That's it. Okay? So hopefully everybody's good with 22. All right? Now, I need a good explanation. What?
Oh, I want to get
What do you want to do?
I want to do number.
Okay, read 23.
We were given $35 to buy the product and it would cost us first day. The fabric costs $6 per item. We have enough money to buy for 4.78 dollars.
Yes or no?
Yes.
Yes, you do. That is correct. All right. Do you want to tell me how you got yes? No, that's not what you did. Come on. Come on, Sienna. I want you to be prepared, okay? All right. I want you to have some confidence. Sit up here. All right. Draw a picture out. Do something. Okay? Listen to the answer. Christine, go. Right, because if it's $6 per yard, and this is how many yards you're buying, let's say it was $6 per yard and you're buying 5 yards. Then you would just say it's going to cost me $30, right? So you can do 6 times 4 7/8. And what did that come out to be? 29 1/4, which means it would cost you $29.25. And you have how much money? So 35. So there you have it. That means yes. There are alternatives. I'm not arguing with you. There all are alternatives. And here's one of them. Go. That's exactly right. That's an alternative. But because we have calculators, do we really need to round? No, but it's okay to round. Yes.
Could you do 35 divided by 6?
Yes, if you did 35 divided by 6, that would tell you exactly how many yards you could buy.
Okay,
So take 35 divided by 6, and you will see that's greater than 4 7/8. Thank you. What?
Well, I did 35 divided by 4 because it's how much money you have.
Yeah, but it's more logical. Listen to me, and I'm not arguing with some of you. All right, I'm just saying it's more logical to put the 35 with the 6. All right? All right, if you divide that out, that will tell you how many yards you could buy. All right, Jack, I want that put away. All right, now for number 24, we've already done this a bunch. Bella, read it to me. So what do I do? I like it a lot. Area equals 17 3/5 inches squared. I like that a lot. All right. Now, don't take her word for it. Take out the calculator, double check, and verify. All right. Area. Whenever you measure area, that's a great point. It's always squares. All right. You're always measuring area with squares. Thank you. All right. Now, for number 25. Good for you. Tell me, Angelina, read it.
A recipe requires 2.5 teaspoons of baking powder, but the only measurements we have. So it's important for the teaspoons. How many times do you need to fill this measuring?
Tell me.
I did 2.5 divided by 1/4.
Yes.
And I got 10.
That's exactly right. 2 1/2 divided by 1/4, and that will be what?
10.
That's right. It will be 10 times. What's the matter? Anybody have any questions with that? If you knew that, that's pretty good. All right, that's pretty good. All right, I'm pretty happy with you on that. All right, now what I want to do is, please, guys, I need to concentrate. All right, I'm going to give you some harder ones now. All right, so I want everybody to go to the very end. Question number 50. Shh, no, you can be quiet. All right, I want everybody on 48, 49, and 50. I'm going to give you about 5 minutes to do those 3 problems. And I'm going to walk around the room and see how you're doing. 48, 49, and 50. Try to show an example of why you did what you did. All right? In other words, kind of show your work. Write down what operation you used. And I believe everybody was okay with B, right?
No.
No? No. Listen, guys, there's no reason to get this. 3/7 means 3 divided by 7. What is 3 divided by 7? Tell me. What? About 0.42. What's 5 divided by 12 about? About 0.41, and we've done 4/9 enough to know that it's 0.44. I don't know what you're telling me. How is this wrong? How is it? Please tell me, Tucker. How did you miss that?
I just didn't know.
That's not helping me now. I'm saying, what, look, you know, I'm not trying to put you on the spot, right? You know what I'm saying? I don't want you to feel bad. I'm not trying to do that. I'm trying to say, how is my explanation not clear? Is it good now is what I'm asking you.
Yeah.
Right? Because I said, most of the time, kids make a mistake because they don't realize a fraction is just a what problem? It's just a division. Because I hope everybody agrees that it's much easier to compare decimals than it is to compare what? Much easier. So if someone tells you to compare fractions, just say, look, I'd rather compare the what? The decimals. And just type the fraction in and see the decimal. True. Now you're smarter. That's all I'm saying. No reason to be upset. Come on, get in the game. I don't care what you do. I don't care how you did it. This is the answer. B is correct. If you don't know the answer is B, now we can talk. You're good now, right? Sienna, you're good now, right? Okay. Now, the hard one. I definitely want to talk to you. Please listen carefully. Most people had a lot of trouble with 49, so I'm going to tell you something right now. We're going to draw a rectangle that's 12 feet by 14 feet. So now you don't have to draw 12 feet by 12 by 14, but I am. All right, so here we go. I'm going to do something 12 by 14. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think that's 12. All right. And this is my room. All right, this is my room. What am I waiting on?
I thought 12 feet wide and on the side.
That's a very good point. Does it matter length and width? No, they're interchangeable. And I'm going to show you why. Okay, I'm going to show you why. All right, because honestly, I am proud of you. That's a pretty good question. The reason why it doesn't matter is because I can take my square and just turn it any way I want. That's why it doesn't matter. Come on, enough.
They said it's
All right.
a rectangular bedroom.
12 by 14 is a rectangle. Shh. 12 by 14 is a rectangle. Do you agree? Did I draw a rectangle?
No, because it looks like it has 40.
Well, that's because it's 12 and close to 14. But I counted. I physically counted. Are you with me on this?
Yeah.
All right. Now, please watch. I'm trying to show you how simple this problem was. All right? Jack, you're still listening. I appreciate it. Watch me, guys. Some of you think it's better to be working. It's not better to be working. It's better to be watching. I promise you. I gave you time to work on your own. Now I'm trying to show you how I would look at it. All right? So this represents how many feet right there? 1. Very good. This represents another one. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 14 feet there. Does anybody disagree with that? Now it says what? That 1 foot is the same as what? 1 what? 1/4 of an inch. So this right here, stay with me, that length represents what? 1/4 of an inch. This length right there represents what? 1/4. This length right here represents what? 1/4. So how many 1/4 do I have, Jack?
1/4 times however many ticks there are.
Well, thank you, Jack. I couldn't have said it better myself. So 1/4 times 14. That's all. 1/4 times 14. So when we did that, that worked out to be 3 1/2 inches. Right? Why are we saying wait? Take your calculator and do 1/4 times 14. All right? You're going to find out there's so many ways to do the problems. All I care about is if you got 3 1/2. All right, it's taking me too long to do the problems today because I keep getting interrupted. All right, if you got 3 1/2 or 3.5, we're in good shape. All right, now, how many along the bottom are there? 12. So how do I figure out how many inches that represents?
You do 1/4 times
1/4 times 12. And that would be what? 3 inches. All right? So it's 3 1/2 inches by 3 inches. Put your hoodie down. I don't like that. All right, I'm happy. All right? Now again, I'm just trying to show you, no, don't, yeah, I'm going to answer your question. But my question is, how is that as an explanation, right, guys? I mean, I looked around and most people weren't sure. They found an area, right? But all we're saying is we're looking at the individual feet and we're converting feet to what? A different size, which is 1/4 of an inch. All right, hopefully that helps. All right, I think always drawing things is helpful. All right, does anybody have any questions with that? All right, because we got lots to do.
So you don't have to find the area?
No, it doesn't say find the area. It just says find the dimensions. When something says find the dimensions, that means the length and the width. Okay? Good job, girl. All right, here we go. Now I'm talking about, okay, 50 I like a lot too. Gray, what did you get for 50? That's okay. That's all right. Yep.
So I blew them out, and 1 cup has 1/12, and then 1 cup has 1/3, and 1 cup has 5/6.
So 1/12, 5/6, and 1/3. What do you think I should do to those fractions? What do you think I should do to those fractions? Shh. This is what's in one bottle. This is in another bottle. This is in another bottle. So what should I do with those quantities? You should add them. So add them real quick, please. And just... One and 1/4. Anybody else get 1 and 1/4?
Yes.
Right? Now, what we want to do, hold on, Jack. Now, what am I going to do? Yes, divided by 3, because we want them to be equal. So we divide that by 3. And when I divide that by 3, what did I get? Shh, he's telling me. $5.12. Everybody happy with that? Yes.
I'm keeping all the same.
Yes, it works out the same too. So like if you did 1/12, this was 10/12, and this was 4/12. And yeah, that's exactly a brilliant way to do that. But now you understand why we're doing that, right?
Yeah.
This right here tells you how many 12ths you have.
Yeah.
And you want to divide them evenly.
I got 15.
Exactly. There you go. See? That's why you should have just told me the answer instead of telling me you weren't sure. And that's why I called on you, because I saw you had the right answer. All right? So there we go.
How would you do it if you did a grade? So
Well, no. What he did was he realized that this 10 had to be smaller. So he gave like 4 over here. That made that 5 out of 12. And this made that 6. So then he gave 1 away, and that made that 5, and he added it over here. So now they all have 5 12. All right, that's kind of the way he looked at it. But again, I really don't want you thinking that way.
Yeah.
I really want you to understand now, you're just finding the total, and because we want everybody to be the same, we divide it. That's what division does. Division takes a number, and it splits it up exactly the same. All right, that's what it does. All right, so I'm going to pause the video for a minute, and I want everybody now to try 45, 46, 47. 45, 46, 47. Quietly for a quick second, please. Again, I think I went around the room, and I think we're okay with 45 now. All right, I think I double-checked everybody. Now, listen. I think B was okay, right?
Yeah. Yes.
B is okay?
Yes.
Yeah.
I mean what I'm saying. Do you hear me?
Yeah.
All right, come on.
I didn't understand that.
Well, I'm not there yet. I'm on 45. I'm making sure everybody's agreeing with 45 is B, correct?
I'm not
Put
sure.
your hands down.
I'm not sure if it quite is, because 4 times 1/2 is literally the same as 2, and it equals 1, and 1 cut in half is.
I'm not sure what you're doing. What are you explaining?
Okay, so on the top.
No. I'm saying, did you understand 45 is B?
He's the correct answer.
Yes.
Okay, that's what I had.
Yes, good. That's all I want to hear. That's all I want to talk about. All right, I thought I went around the room and checked everybody's, and I thought everybody was good. All right. Now, I want to talk about 46. 46 is a little bit tricky. All right. So here's what I want to talk about, Tucker. Now, instead of continuing, pay attention. That's all. And come on. All right. I know it's a frustrating day. These are hard. Guess what? These are from a high school test. They're supposed to be harder. All right? Come on. I'm giving them to you because you're smart enough to do them. You hear me? Come on, buddy. Relax. What I want everybody to realize is this real quick. All right? I'm going to draw me one budget. All right? Here's what I'm saying. All right? That is one budget right there. That's all the money in one pile. Does everybody agree with me? Right? Now, what I'm going to do now is I'm going to spend 1/9 of it on library books. So now watch how I represent spending 1/9 of it. This is what you're supposed to be able to do. All right? This now right here represents, what did I just do? I just spent 1/9. All right, does everybody agree with that? I just spent 1/9. Now keep in mind, that's one budget, right? So can somebody tell me how much of the budget is left?
Wait, no.
You're not even paying attention. What? How much?
8/9.
8/9 is what's left. Because I just used what? 1/9. Now, come along, and now I have to pay for a scholarship. So now what I'm going to do is I'm going to come over here and I'm going to chop that off. Now, what does that represent? What? What is that? That represents 1/6. So I've just chopped off 1/6, and I've just chopped off 1/9. So the question is, how much remains? What would I do?
You get what you got, and then you subtract the 2 numbers.
From what?
From.
Well, you got the right answer.
Yeah, I got it. I can't really explain.
Well, here's what I'm going to tell you. Now listen to me right now. Listen to me. This is important. Very important. This right here, I'm trying to tell you. Because I don't give you a total, I'm trying to tell you, what does this whole thing represent?
1.
1. That's exactly right.
That's what
Yes. So you're going 1 minus 1/9 minus 1/6. Now, you don't have to tell me, guys. Come on now. You know me now enough. You don't have to tell me, well, I did 1/9 plus 1/6, then I subtracted that from 1. You don't have to tell me because I know that. All right? I'm trying to make sure the people who had trouble understand exactly what took place. Tucker, does that make better sense now?
Yeah.
Right? Come on. Don't be frustrated by the problems. They're challenging you. All right? One whole budget, I spent 1/9 and then I spent 1/6, so I simply subtracted that. And when I subtracted those, what did I end up getting?
13/18.
Yes, H was correct. 13/18. All right, that was nice. Hopefully you're seeing it a little better. All right? Hopefully you're seeing it better. All right? Now, let's take a look at number 47. What? Tell me what you got for 47.
47, I got 4 and 13.
I'm proud of you, actually. That's a good job. I think it's D.
Yeah.
D, are we okay? Now, let me show you something on this one too. Put your hands down. I appreciate it. We're going slow, so I need to pick up the pace. So I want to show everybody this. Look, everybody, we need to know how much that is from there to there, which is obviously just what? 11 5/8. Then we said from here to here is how much? And then from here to here is what? Now the question actually is stating how much is it from here to here. That's what it's kind of stating. But what you should be smart enough to realize is that right there is the same as that piece that's missing right there. Does everybody agree with that? So all we had to do was simply take 11 5/8 and subtract out 2 1/16 and 4 3/4. That's all we had to do.
I did that and I didn't get the right.
Well, we got to talk about your calculator then. Let's do. Get your Shh. Take your calculator. Let's go. So it's 11 5/8 minus 2 1/16 minus 4 3/4.
Yeah, I got 4 7 4.
Well, that just means you typed it incorrectly. Maybe you just didn't see the numbers correctly. So type in again 11 5/8. Clear everything out. 11 5/8 minus 2 1/16 minus 4 3/4. Everybody finish these problems up. All of them tonight. Try. They're easier. They're easier. What did you get? You see what I'm saying? Now I want to talk to you for a second. Yeah, the rest. All right? The rest of them. The ones before that are much easier. Get busy. Get busy.